Dear students, in the previous session, we have already discussed some basic properties. They are one function, onto function, bisective function, and inverse of a function, composite function, and important one, even and odd functions. They are discussed. Now continue some basic properties and some special type of functions in this session. Right. The first one, periodic function. A function is said to be periodic function. There exists a positive real number t. There exists a positive real number t such that f of x plus t is equal to f of x. Right? There are many values of t satisfying this equation. At that time, what is the period of a function? Right. The least positive value, the least positive number t is called its period or the fundamental period. In other words, periodic function is a function that repeats its values, after every particular interval. Right, this is the periodic function, and this is the way to define the period of a function. Right. Now, the period of trigonometric functions are sin x, cos x, the reciprocals, cosecant x, secant x. The period of these four functions, is 2 pi. Period of these four functions is 2 pi. The period of tan x, cot x, the period of tan x, cot x, the period is pi. Now, there are three different methods for finding period of a function. Right. Let us see the first method. This is the first method for finding period of a function. Right. If f of x is a periodic function with period p, if f of x is a periodic function with period p, then the period of f of ax plus b, then the period of f of ax plus b, or k times f of ax plus b, or the period of the function k times f of ax plus b plus l is the same. That is, the period of this function is p by mod a, where a is the coefficient of x, Right. This is the first method. Suppose, see the example, sin 2x plus 3. What is the period of this function? The period of sine function is 2 pi. Here, this is of the form sin of ax plus b, so that the period of this function is 2 pi divided by, here coefficient of x that is 2. 2 pi by 2 that is equal to 2. That is the period of sine of 2x plus 3. Now, what is the period of tan of 6 minus 5x? What is the period of tan of 6 minus 5x? The period of tan function is pi. Here the coefficient of x. The coefficient of x is minus 5. Pi by mod a modulus of minus 5, that is equal to pi by 5. That is the period of 6 minus 5x. Right. Now go to second method. Go to second method. By using second method, how to find the period of a function? Right. In this case, let f of x is equal to a into f1 of x plus or minus b into f2 of x plus or minus c into f3 of x plus or minus d into f4 of x. How to find the period of this type of functions? Here f1, f2, f3, f4 are the linear functions. It means the degree of that functions are 1. Or f of x is of the form a into f1 of x plus or minus b into f2 of x divided by c into f3 of x plus or minus d into f4 of x. Right. For this type of functions, how to find the period? Right. First find the period of individual functions. Suppose the period of f1 of x, period of f1 of x, that is equal to p1. The period of f2 of x, the period of f2 of x, suppose the period is p2. The period of f3 of x, the period of f3 of x, that is equal to p3. The period of f4 of x, the period of f4 of x, that is equal to p4. First find the period of the individual functions. Now the period of the given function is equal to the period of the given function is equal to LCM of the periods of P1 comma P2 comma P3 comma P4. That gives the period of the function f of x. Right. See one example. Let f of x is equal to f of x equal to 2 into sin x plus 3 into cos x divided by 4 into sin 2x, 4 into sin 2x minus 5 into cos 2x. Right. Find the period of f of x is equal to this. Right. First find the period of individual functions. The period of sin x comma cos x is equal to the period of sin x comma cos x is equal to 2 pi. The period of sin 2x comma cos 2x, the period of sin 2x cos 2x is equal to 2 pi by 2, that is equal to pi. Now, the period of f of x is equal to the period of f of x is equal to LCM of pi comma 2 pi. LCM of pi comma 2 pi, that is equal to 2 pi. Right, this is the way to find the period of this type of functions. Now go to third method. Go to third method. By using the definition of a periodic function, that is f of x plus t is equal to f of x. By using the definition of a periodic function, by finding the period of a function. Right. See one example. Let f of x is equal to x minus box x. F of x is equal to x minus box x. Right. Okay. Let suppose f of x plus t, f of x plus t, that is equal to x plus t minus box of x plus t, where t is an integer, where t is an integer, where t belong to z. Right, here t is an integer, so this can be written as x plus t minus, particularly this box of x plus t, where t is an integer, that is box x plus t. Now t gets cancelled, that is equal to f of x. Right, f of x plus t is equal to f of x. This is true for all integers. This is true for all integers. Right, now at this time, what is the period of a function? What is the period of a function x minus box x? The period of f of x is equal to the period of f of x is equal to the period is least positive integer. By the definition of period, the period of the given function is equal to least positive integer. Least positive integer. Least positive integer means that is 1. Therefore, the period of this function is 1. Right, these are the three different methods for finding period of a function. Okay, right. Now, increasing and decreasing function. Right. How to define increasing and decreasing function? Okay, generally all of you know increasing and decreasing. Okay, now in the functions, how to, at what time the function is said to be increasing, at what time the function is said to be decreasing. Right, see the definitions. A function is said to be an increasing function if the values of y increases with the increase in x. Okay, if the increase in x, then y increases, then that function is an increasing function. See one example. See one example. This is x, this is y, y is equal to sin x, y is equal to sin x. Right, the values of x, 0, pi by 6, pi by 4, pi by 3, pi by 2. Now the corresponding values of y. Here the values of x are in increasing order. The values of y are sin 0, 0, sin pi by 6, 1 by 2, that is 0.5, sin pi by 4, 1 by root 2, that is equal to 0.7, sin pi by 3, root 3 by 2, that is equal to 0.8, sin pi by 2 is equal to 1, right? See this, here the values of x increases, then the values of y also increases, then the function sin x in the interval 0 comma pi by 2 is an increasing function, right? Now, a function is said to be a decreasing function. If the value of y decreases, with the increase in x, if x increases, then y decreases. In this situation, the function is said to be a decreasing function. See one example. Same, the values of x are 0, pi by 6, pi by 4, pi by 3, pi by 2. Now, function y is equal to cos x. Y is equal to cos x. Cos 0, that is equal to 1. Cos pi by 6, that is 0.8. Cos pi by 4, that is 0.7. Cos pi by 3, 0.5. Cos pi by 2, 0. Here, the values of x are increases, then the corresponding values of y decreases from 1 to 0, right? Therefore, cos x is a decreasing function in the interval 0 comma pi by 2. Okay. Right, now we are going to discuss some special types of functions. Okay. Okay, mainly there are two types of functions. See, the two types are, first one is implicit function, the second one is explicit function, right? What is the difference between these two functions? Okay, mainly implicit function and explicit function. Okay, for the clear understanding, first I am giving examples of these two functions. The example for this function is, ax square plus 2hxy plus by square is equal to 0. This is a function of two variables in x and y. This is a example of implicit function. Now, the example of explicit function is, y is equal to ax square plus bx plus c. Y is equal to ax square plus bx plus c, right? So, these are the examples of, this is implicit and this is explicit. Right. So, from this, why this is called an implicit function? Okay, in this equation, we cannot write y in terms of x or x in terms of y. In this, x is called independent variable, y is called dependent variable. Here, x and y cannot be separated. So, that's why this is called an implicit function. Here, clearly, y can be written in terms of x. Right. This is called an explicit function. Now, our entire discussion in functions go to explicit functions. Right. Now, the explicit functions are, right, first one, polynomial function, very, very frequently used in all areas of mathematics. That is a polynomial function. That is very familiar to all, right? F of x is of the form a naught into x power n plus a1 x power n minus 1 and so on a n. The particular condition in this is a naught not equal to 0. A naught not equal to 0. A naught comma a1, a2 and so on. An are complex numbers and n belong to, n is a whole number, is called, this is a polynomial of degree n. This is a polynomial of degree n if a naught not equal to 0. Right. This is the polynomial function. Right. What is the domain of the polynomial function? What is the domain of the polynomial function? The domain of the polynomial function is the set of all real numbers. Right. Now, see one example of a polynomial function. Right. Here, this is a linear polynomial. Linear polynomial means this is a polynomial of degree 1. This is a polynomial of degree 1. F mapping from R to R by f of x equal to ax plus b. This is a linear polynomial. Right? How to draw the graph of a linear polynomial? Right. Suppose f of x is equal to 2x minus 4. F of x is equal to 2x minus 4. This is also a linear polynomial. F of x is the same as y. Y is equal to 2x minus 4. Now, draw the graph of this line. That implies 2x minus y is equal to 4. Now, write the line in intercept form. That implies x by 2 plus y by minus 4 is equal to 1. Now, the x-intercept is 0, 2. That is on positive x-axis. X-intercept on positive x-axis. The y-intercept is 0, minus 4. The y-intercept is 0, minus 4. Right. X-intercept is 2, 0. Now, the y-intercept is minus 4. That is the point 0, minus 4. 0, minus 4 on a negative y-axis. This is 0, minus 4. Now, this is a straight line passing through these 2 points. Right. This is a linear function. Okay. Now, whether this function is 1, 1, onto and bisective. Right. By using horizontal line test, clearly this is both 1, 1 and onto. If we draw horizontal line parallel to x-axis, if we draw a horizontal line parallel to x-axis from the points in the codomain, it intersects at only one point. Then it is a bisective function. Right? Remember, if f mapping from R to R defined by f of x is equal to ax plus b, that is a linear function. This is a bisective function from R to R or Q to Q. This is also a bisective function. Okay. Right. Now, f mapping from R to R defined by f of x equal to x square. Right. This is also a polynomial function of degree 2. Right. See the graph of this function. F of x equal to x square is the graph of this function is a parabola. The graph of this function is upward parabola. Right. Now verify the function is 1, 1, onto and bisective. Right. Now draw a horizontal line. Draw a horizontal line. Right. This horizontal line intersect at 2 points. This is x1 comma y1. This is x2 comma y1. x2 comma y1. Right. If the horizontal line intersects at most one point, in that case only it is 1, 1 function. Here the horizontal line intersect at 2 points, therefore it is not 1, 1. Now go to onto. Now draw a horizontal line. Draw a horizontal line from the points in the codomain. Here the codomain is set of all real numbers, that is minus infinity to infinity. Now this is a horizontal line from the points in the codomain. So this horizontal line does not intersect the graph. This horizontal line does not intersect the graph. The actual definition for the onto function is any horizontal line from the points on the codomain intersects the graph at least at one point. That is the definition. But here the horizontal line does not intersect the graph, therefore it is not onto. Okay, f of x equal to x square defined from R to R. This is not 1, 1, not onto. F is neither 1, 1 nor onto. F is neither 1, 1 nor onto. Right. Now f mapping from R to R defined by f of x equal to x cube. This is also a polynomial of third degree. Now what is the graph of this function? Right. If x tending to minus infinity, this is minus infinity, this is plus infinity. As x tending to minus infinity, f of x tending to minus infinity, suppose let it be denote some point. Suppose x equal to minus 1, f of x equal to minus 1, x equal to minus 1, f of x is equal to minus 1. Suppose this is a point minus 1 comma minus 1. Now put x is equal to 0, y is also equal to 0. Now f of 1 is equal to 1. Suppose this is a point 1 comma 1. Now x equal to infinity, f of infinity is equal to infinity. Suppose this is a point. Okay, now join these points. Now join these points to get a graph of f of x is equal to x cube. Right. Okay. Now verify this is 1, 1, onto and bisective. Right. Now draw a horizontal line from the points on the codomain intersect at only one point. Okay. Now draw a horizontal line from the points on the codomain intersect at only one point. In this case, we say that this function is a bisective function. Right? Moreover, f of x equal to x cube is an odd function. the graph of this function is symmetric about the origin. So this is an odd function. Also, if x increases from minus infinity to infinity, then f of x is also increases. Therefore, f of x equal to x cube is an increasing function. Right. Okay. Here f of x equal to x square. This is an even function since the graph is symmetrical about y-axis. Also, if x increases from minus infinity to 0, okay, observe this, x increases from minus infinity to 0, f of x decreases, okay. So, in the interval minus infinity comma 0, f of x equal to x square decreases. Now, from the interval 0 comma infinity, the values of f of x increases. Therefore, in the interval 0 comma infinity, the function is increasing. Right. Now, another function, rational function. Okay, rational number is known to all. Rational number means it is a number is of the form p by q. Now, how to define a rational function? Right, f of x comma g of x are the two polynomials defined on the same domain A, and particularly g of x not equal to 0 for all x belong to domain. Then h of x is equal to f of x by g of x. Here also h of x is of the form f of x by g of x. This is called a rational function. In this case, particularly provided g of x not equal to 0. Now, see the example of a rational function. Example of a rational function, f of x is equal to x plus 2 divided by x plus 3. This is a rational function. Now, one more example, g of x is equal to 2x square minus 3x plus 7 divided by x minus 1. This is also a rational function. Right, now see some another examples of a rational function. Let f mapping from R minus singleton set 0 to R by f of x is equal to 1 by x. This is also a rational function. Now, what is the graph? The graph nature? Okay, right. F of x equal to 1 by x, x tending to 0 plus, x tending to 0 plus, x tending to 0 plus, that implies 1 by x tending to infinity, 1 by x tending to infinity, x is equal to 1, x equal to 1, that implies 1 by x is equal to 1. Now, x tending to infinity, x tending to infinity, 1 by x tending to 0, right? Now, the graph is like this, x tending to 0 plus, 1 by x tending to infinity. So, suppose denote this point. Now, x equal to 1, 1 by x equal to 1, this is 1 comma 1. Now, x tending to infinity, 1 by x tending to 0. Suppose this is a point, right? Now, join these 3 points. Now, join these 3 points, right? This is one side. Now x tending to 0 minus x tending to 0 minus, that implies 1 by x is equal to minus infinity. X tending to 0 minus 1 by x tending to minus infinity. X tending to 0 minus x tending to 0 minus 1 by x tending to minus infinity. X equal to minus 1, that implies 1 by x is equal to minus 1. X tending to minus infinity, 1 by x tending to 0. Right? Now see the graph. X tending to minus infinity, 1 by x tending to 0. Suppose let it be that point. Now minus 1 comma 1, minus 1 comma 1 is a point. Now 0 minus, that implies 1 by x tending to minus infinity. Suppose this is a point. Now joining these points to get a graph of 1 by x. Right? This is the graph of f of x is equal to 1 by x. Graph of f of x equal to 1 by x. Now verify this function is 1 1 onto bisective function. Right? Now draw a horizontal line from the points on the codomain that intersects at only one point. Now this is a horizontal line, intersect the graph at only one point. Now draw another horizontal line, this also intersect at only one point. Therefore f of x equal to 1 by x is a bisective function. Right? Also this is an odd function. This is an odd function. Right? Okay. Now see another example. F mapping from R minus singleton set 3 to R minus singleton set 1 by f of x is equal to x minus 2 by x minus 3. Now how to draw the graph of this function? Also verify this is 1 1 onto and bisective function. Right? For the drawing the graph of a function, okay, y is equal to x minus 2 by x minus 3, x minus 2 by x minus 3. Y minus 1 is equal to y minus 1 is equal to x minus 2 by x minus 3 minus 1. By taking LCM, x gets cancelled, 1 by x minus 3. Now y minus 1 is equal to 1 by x minus 3. Right? The graph of this function is the same as the graph of the function f of x is equal to 1 by x, but there is some difference. Okay, here in this graph, this is the origin. The origin is shifted in this graph is 3 comma 1. Here the origin is shifted to the point 3 comma 1. Suppose this is a point 3 comma 1. Right? This is a point 3 comma 1. Now draw a horizontal line passing through 3 comma 1 and draw a vertical line passing through 3 comma 1. Now draw the graph of this function. Also observe that this is a rectangular hyperbola. This is also a rectangular hyperbola. Right? Here, this is a point x is equal to 2. Put x is equal to 2. Y minus 1 is equal to minus 1. Y is equal to 0. Right? This is a point 2 comma 0. This is a point 2 comma 0. Also, put x is equal to 4. X is equal to 4. This is equal to 1. Y is equal to 2. Y is equal to 2. Right, this is 4 comma 1. Now, the corresponding point is 4 comma 2. Right, now the graph of this function is, now the graph of this function is same as the graph of the function 1 by x. Right, in this side, this is right, this is the graph of the function f of x is equal to x minus 2 by x minus 3. Clearly, this function is also a bisective function. Okay. Right, now constant function. Right, how to define constant function? A function is called a constant function. The range of f contains one and only one element. The range of f contains only one element. That means that the image of all domain elements is only one element. The image of all domain elements is only one element. In that situation, that function is called a constant function. Right? F of x is equal to c for all x belong to a. Right? Now, how to draw the graph of this constant function? Right? F of x equal to c, or let f of x is equal to 2. F of x is equal to 2. It means y is equal to 2. Y is equal to 2. The graph of a constant function is a straight line. Moreover, that is parallel to x-axis. That is parallel to x-axis. This is the graph of a constant function. This is a point 0 comma 2. This is a straight line. Y is equal to 2. Now, this is 1 1. This is not 1 1 function, since many elements having same image, so that it is not 1 1. It is onto function. This is onto function only when, if the codomain contains only one element. If the codomain contains only one element. Right? Now, what is the period of this function? F of x equal to c, the constant function is a periodic function, since f of x plus t is also equal to f of x plus t is also equal to c. That's why this is a periodic function. Now, define its period. This is true for all t belong to R. This is true for all t belong to R. Now, the period of f of x is least positive real number. The period of f of x is least positive real number. But the least positive real number is not defined. The least positive real number is not defined. That's why f of x equal to c is a periodic function, but does not have a period. Right. Now, identity function. F mapping from a to a by f of x equal to x for all x belong to a. Right? It means that f of y is equal to y, f of z is equal to z, f of x1 equal to x1, but the element of domain, the image of the domain element is same its element. Okay, so that is identity function, the and is denoted by IA, and is denoted by IA. Now, how to draw the graph of identity function? Right, identity function means that is a straight line y is equal to x. The graph of this function is a straight line, that is y is equal to x, y is equal to x. Right, this is y is equal to x. Clearly, this function is a bisective function. This function is a bisective function. Right. Now, logarithmic function. F of x is equal to log x base a, where a greater than 0 and a not equal to 1 and x greater than 0 is called a logarithmic function. What is the domain of a logarithmic function? What is the domain of a logarithmic function? Logarithm is only defined for positive real numbers. Logarithm is defined only for positive real numbers, so that the domain of a logarithmic function is r plus. And what is the range of logarithmic function? Range of logarithmic function, that is r set of all real numbers. Right. Now, how to draw the graph of this function? What is the shape of this function? This is a bisective or not? Also, this is an increasing or decreasing. By using graph, we discuss these points. Right. Here, the very important is a not equal to 1. A not equal to 1. A not equal to 1 means a lie between 0 and 1, 0 less than a less than 1, or a greater than 1. Now we draw separate graphs for a lie between 0 and 1 and a greater than 1. Right. In the case of a lie between 0 and 1, x tending to 0 plus. X tending to 0 plus, it means 0 less than x less than 1. X lie between 0 and 1. A also lie between 0 and 1. Log x base a is positive. Log x base a is positive. As x tending to 0 plus, this goes to plus infinity. Suppose let it be at that point. Now put x is equal to 1. Log 1 to any base is equal to 0. Log 1 to any base is equal to 0. Right. Now x tending to infinity. X tending to infinity and a lie between 0 and 1, that is equal to minus infinity. That is equal to minus infinity. Suppose denote this. Now join these points. We get the graph of log x base a, where a lie between 0 and 1. Right. Now draw the graph of log x base a, where a greater than 1. Right. Here a greater than 1, x lie between 0 and 1. A greater than 1, x lie between 0 and 1. Log x base a is negative in this case. Right. that is minus infinity. Suppose denote this point. Now log 1 to any base is equal to 0, right? As x tending to infinity, log x base a tending to infinity, right? Now joining these points, we get the graph of log x base a, where a greater than 1, right? Particularly in this case, 0 less than a less than 1. If the values of x increases, then log x base a decreases. X increases, log x base a decreases. So a lie between 0 and 1. In this case, logarithmic function is a decreasing function. Now, in the case of a greater than 1, x increases from 0 to infinity, log x base a increases, log x base a values are increases from minus infinity to infinity, right? In this case, log x base a is an increasing function, right? Thank you.